Okay, today you're going to basically take your skills of adding, subtracting rational expressions and simplifying everything to actually apply them to solving rational expressions. Okay, so today you guys are going to be able to solve a rational expression in one variable. And so let's start here by using cross products. Now, let's take a look at this. If you have x over 2 equals 1/4. A long time ago, like way before Algebra 2, you guys learned how to solve these types of problems. What would you have to do here? What would you have to do to solve this problem? Exactly, you would have to cross multiply. So you will multiply the x times the 4 to get 4x, and then 1 times the 2. Okay, and so then from there you would solve it. So then you would get, so then you would divide both sides by 4, and you would get x equals 2/4. I think y'all thinking about like adding like just fractions. There's an equal sign in between. Okay, so x equals 1/2. Do y'all remember doing this at some point in time? It's called cross multiplying. Okay, you can do that with the rational equations as well. Okay, so let's say you have a fraction equaling to another fraction. Okay, you can use cross multiplying to solve for your variable. Okay, so that means I'm going to multiply 8 by x minus 3, and I'm going to set that equal to 3 times x plus 7. And then you will, of course, want to distribute the 8 and do your algebra to solve for your variable. Okay? So that becomes 8x minus 24 equals 3x plus 21. Yep. Get your variables on one side. Get everything else on the other side. And then in this case, divide by 5, and x equals 9. You can always check your solution by what? Plugging it in. Anytime you're solving any type of equation, you can always check your solution by plugging in. Now, depending on the answer, it could be something that's really crazy. But really and truly, okay, and I can at least say this for algebra 2. I don't know about for pre-cal or calculus. You definitely want to make sure you always check with those. But if you go to plug your value back in and it doesn't make the denominator 0, then you know it's the solution. Okay? You know it's going to be the solution. But if you have the time, plug it back in and make sure it works. What's 7 plus 9? 16. And what's 9 minus 3? 6. This is 1/2, right? So then it works. I want you guys to do this one. Watch your sign. Watch your sign. All right. So multiplying by the LCD. All right. Now, if you notice in this case, These are not one fraction equal into another fraction, so I can't use cross products, but what I can do is I can try to identify what's my common denominator between every single term. And what's my common denominator? X plus 7. Now, the way that I do it is I multiply by whatever the denominator is missing, okay? And by doing that, it allows me to get rid of the denominator altogether. So, if the lowest common denominator is X plus 7, what is this first fraction's denominator missing to make it be the common denominator? Nothing. So then I can just write an X. But this one, what is it missing to be the common denominator? So I'm going to multiply this negative 3 by an X plus 7. And that's going to equal negative 1 because that denominator is not missing anything at all. And by multiplying by the lowest common denominator every term, or by whatever it's missing to get the lowest common denominator, I can just get rid of them. Okay? Because essentially it's going to be the exact same thing across the board. So that's negative 2x minus 21 equals negative 1. Add 21, divide, and x equals negative 10. When I look at example B, what's my LCD? X minus 8. So again, this one I'm going to treat it as an over 1. So my common denominator was x minus 8. Am I going to multiply the first fraction by anything? No. What about the second fraction? And what about this fraction, the last one? Nothing. So that gives me negative 2 plus x squared minus 8x equals 7, making sure I distribute that x over. Looks like I got another quadratic, yes? X squared minus 8x equals negative 9, or minus 9 equals 0. How does this factor? X minus 9, x plus 1. So my two solutions are 9 and negative 1. They both work? Yes, they do. None of them make my denominator 0. And like I said, this is algebra 2. We ain't going to give you nothing that's like super crazy. It's going to work if the denominator is defined, okay? So. Because you said both of them equal to 0. So you get x equals positive 9, and then you do the same thing for the next factor by subtracting 1. Okay? Let's look at the next ones, where you have to factor to get to the lowest common denominator. Okay? And even though, yes, this one here, you have a fraction equaling another fraction, that's a skill we have in our back pocket. But to kind of harp on these types of problems, can I factor this denominator here, the one on the left? Yes. This one is difference of perfect squares. X plus 2 and x minus 2. Between that denominator and the other denominator, what is my lowest common denominator? X plus 2, x minus 2. Because both denominators have an x plus 2 in common, that's a common factor, but the right fraction is missing an x minus 2 that the left fraction has. So you're going to need an x minus 2 there to be your lowest common denominator. So this fraction over here on the left, is it missing anything? So I leave that as x plus 6. But the one on the right-hand side, I'm going to need to multiply by what? X minus 2. And like I said before, you can get rid of the denominators there. And so you'll get x plus 6 equals 3x minus 6. Subtract an x. Add a 6. And x equals 6. And in case you were wondering, I could have cross multiplied this. And gotten the same thing. I just would have had to do a little bit more work. Okay? I just would have had to do a little bit more work. A lot more work. That's a whole lot. A lot more work. X equals 6, X equals -2. But if I did it this way, where I used the cross products, I know I did it really, really fast. I know I did. But all I did was cross multiply because I had a fraction equaling another fraction. I distributed, combined like terms. I got everything equal to 0. I factored it, and I solved it. These are my solutions. But what's wrong with this X equals -2? It's extraneous because if I plug -2 in back up here, what's -2 plus 2? And you can't have 3 over 0. It's undefined. That's why X equals 6, the one we got when we did the common denominator, is correct. Okay? So, you still get the same answer both ways. To be honest, you do a little bit more work on the black, but you still get the same answer. Let's look at this one. All right. Look at this one. Hopefully you notice that I'm going to have to factor this denominator. What two numbers multiply to give me 27 that add together to give me 12? So this breaks down to be x plus 9, x plus 3. So what's my lowest common denominator? X plus 9, x plus 3. Basically, whatever the denominators have that the other denominators are missing, that is your lowest common denominator. Sometimes it could be only 2 things. Sometimes it could be 3. No more than 4. Okay. So what do I have to multiply this fraction by? So this just becomes x plus 9 because it's x plus 9 times 1. What do I have to multiply this fraction by? X plus 9 and an x plus 3, which is just the FOIL, which was what I had before. Let me delete this right now. What do I have to multiply the last fraction by? Nothing. So now it's just a little bit of algebra that you have to do to solve. Go ahead and FOIL, distribute, solve for x. FOIL, distribute, and solve for x. Okay, so let's see how you guys did. Now you could either distribute first and then multiply, or you could FOIL first and then distribute. If you choose to distribute the 2 over, only distribute to one parenthesis, not both. But me, I am going to FOIL first. It says x squared plus 12x plus 27. And then I'm going to distribute over the 2. So it becomes x plus 9 plus 2x squared plus 24x plus 54. What? If you decide to distribute over the 2 first before you FOIL, only distribute to the x plus 9, not to both parentheses. Okay? So now when I combine like terms, that gives me a 2x squared plus 25x plus 63. And this is still a quadratic, so I'm going to set everything equal to 0. Subtract over an x squared and add over a 3. Is everything okay? All right. What are my two numbers that multiply to give me 66 that add together to give me 25? 22 and 3. So I have x plus 22, x plus 3, and I have to set both of these equal to 0. So x equals -22 and x equals -3, but I have to check. When I plug -3 Back in up here. You get 0 in the denominator. So this one is an extraneous solution. So my only answer is 22, negative 22. And that's how you solve rational equations. Does it get harder? Depending on what you're given, to be honest. Depending on what your original equation is, that's as hard as it's going to get. Okay? Question. It is possible for there to be no solution. So you go through the math, you multiply, and then once you get your solutions, when you plug them back in, they're both extraneous. They both make the denominator 0. In that case, then there is no solution. Good question. Okay? Other questions?